Good morning, Math 2. So this is a very, very short lesson on new content because as you'll see, I did post a review problem set that is all drawn from the back of your book and has the answers in the back, as you know. You'll also notice I put in the calendar a 2:15 Thursday drop by help time, okay? All right, so what I want to first do to kind of lead into the new content is go over question 515 and 516, which we did not have a chance to go over when I met with you. So 515 asks you to, you're just going to follow my pen here. It says you're given these two statements. Part A asks you to rewrite A and B as powers of 10. And then part B says, what is A times B? Well, A times B is 10 to the M times 10 to the N, which then equals 10 to the M plus N. So, and here I highlighted this because this is another property of logarithms, all right? I want you to follow my pen, okay? So this left-hand side says the exponent that you raise 10 to get A times B, which we know is M plus N, equals the exponent you raise 10 to get A, which is M, plus the exponent that you raise 10 to get B, which is N, right? So the left-hand side is saying, basically the exponent you raise 10 to, okay, to get 10 to the M plus N, which is here, okay? So basically what this property is talking about is the relationship between, if you have log base 10 and it's A times B, this becomes log of A plus log of B. What most people do when they see this for the first time is they'll say, oh, log of A times B equals log A times log B, times, right? Like they'll do this weird distributing of the log to the A and B and then keep the times, and that is not correct. And the reason why is because of this up here. They just walked you through it, right? That you saw here that that 10 to the M, which is A, times 10 to the N, which is B, equals 10 to the M times 10 to the N, which means 10 to the M plus N, plus, okay? 516 is a property that I already showed you, but they just kind of, revisited it. So here's the property. So property of logarithm, brand new one here. Property of logarithm, old one, revisited. And I just kind of went and did like a state. I said, why is this true? Well, let's see. For example, if I have log base 10, again, right? Log base 10 of 10 to the 14th, right? This question is saying to you, what is the power that 10 has to be raised to get 10 to the 14th? And if you say that statement a couple of times, what is the exponent that 10 is raised to get you to 10 to the 14th? Well, obviously, if you want to take the base of 10 and raise it to a power to get you 10 to the 14th, well, that's just going to equal 14, okay? And what I did here, we'll go down here in a second, and you'll see that 14 is the answer. And that is the same thing as, taking this 14 and swinging it out in front, which is 14 times log base 10 of 10. And this works because I just lost my train of thought. Anyway, okay, sorry. I think I just did I think my eyeball was like looking down here. I thought I was writing. But anyway, okay. So here I kind of rewrote this. I'm going to erase this so we don't get confused. Okay. So I think down here I did it a different way. I just said, okay, well, let's pretend log of 10 to the 14th equals question mark. And then I just rewrote this equation exponentially, right? 10 to the question mark equals 10 to the 14th. Well, if 10 to the question mark equals 10 to the 14th, then obviously question mark has to equal 14, okay? And what I have here is question mark equals 14, and that equals 14 times log 10, like the exponent swings out front. So there is another property of logarithms, just revisited. And then part B, there's this one. Okay, they gave you this and they said, well, okay, why is this true? Well, let's see. So I gotta shrink down a little bit. I just used the information from part A, right? I started with the same starting point. If m equals log A and n equals log B, and notice I'm just saying m equals log A, I'm no longer saying m equals log base 10 of A. It's understood at this point, understood. Well, m equals log A is the same thing as saying 10 to the m equals A. And n equals log B is the same thing as saying 10 to the n equals B. And then I said, well, what is A over B? Well, A over B is 10 to the m over 10 to the n, which equals 10 to the power of m minus n by properties of exponents. So what you'll see here, if you follow my pen, okay, the exponent, right, that 10 is raised to get me to 10 to the m minus n, right, is precisely the exponent that 10 is raised to get me to A, which is m, minus the exponent that 10 is raised to get B, which is n. There's another property of logs. So right here, I'm going to say that 1, 2, 3 properties of logarithms, right? And how do you use these properties? Well, I'm just going to go back and show you. And it just occurred to me that, how sometimes I'll say a statement and I'll repeat it. I just realized in a screencast, I don't have to repeat because you can always just hit rewind. What a ding dong. Okay, so now we're going to go into 513. I'm going to do 513 part A and part B with you so you see what's being asked of you now. So you are starting here. They say start with these statements. They're giving you 10 to the 0.301 is approximately equal to 2, and 10 to the 0.477 is approximately equal to 3. And the question here is, well, what is 10 to the x? What is x if 10 to the x equals 6? Okay, well, what I'm going to do is I'm going to first rewrite this exponential equation. I'm going to rewrite it logarithmically. So let's see. Log base 10 of 6 equals x, right? And the question is, well, what is x? Okay, I'm going to rewrite 6, though, as this. Watch. Log base 10 of, not 6, but just write log base 10 of 2 times 3, right? Because that also equals x. And then I'm wondering, how can I rewrite log base 10 of 2 times 3? Well, what about this property right here? Log of A times B, we're told, equals log A plus log B. Well, that tells me then that log of 2 times 3 just equals log 2 plus log 3. But what's log 2 and what is log 3? Okay, everyone listen up. What is log base 2? What is the power that 10 is raised to give you 2? What is the power that 10 is raised to give you 3? The power that 10 is raised to give you 2 is none other than 0.301. The power that 10 is raised to give you 3 is 0.477. So log base 2 of log 3 is 0.301 plus 0.477, which equals 0.778. And I have just solved for x. And don't lose sight of the fact that what's x again? X, don't forget, x is the power that 10 is raised to get you to 6. Okay? I'm going to do part B with you. Let's rewrite this logarithmically. So 10 to the x equals 8 is the same thing as saying log base 10 of 8 equals x. Okay. How could I rewrite this number 8 in here in terms of 2 and or 3? Well, let's see. This is the same thing as saying log base 10 of not 8, but let's call it log base 10 of 2 cubed. That also equals x. Okay, what property is that? I believe it is this one, right? Well, log base 10 of 2 cubed equals x. This is the same thing as power of the 2 swings in front, 3 times log of 2. Okay, but let's see. This is 3 times, once again, what is log base 10 of 2? What is the exponent that 10 is raised to get you to 2? 0.301. And at the end of the day, we have, what is this, 0.903? That is the answer. That's the value of x. That's the value of x. That is the power that 10 has to be raised to get you to 8. Okay, so this is just a very short new lesson, but a powerful one, because we have three properties of logarithms that we just kind of covered, introduced, and in the case of this one here, reinforced. Okay, what I'd like you to do just to practice these 3 skills, these 3 properties of logarithms, and using them in this way are not going to be on the test on Friday, as you can see from my page ranges. But I would like you to finish 513 and also do 514, okay? Just right now after listening to this, okay? All right, everyone, I will see you. You'll see here that I put up a 2:15 open session for us only, Math 2 on Thursday, okay? I'll see you then. All right, goodbye.